What's up, guys? Let's take a look at another CodeWars exercise. This one's called moving zeros to the end. We've got a list, and sprinkled throughout are zeros. We want to keep the same stuff in the list, same length, same items, but rearrange it so that all the zeros are at the end and everything else keeps the original order. So let's give it a try. There are a lot of ways to do this. My first thought was to use the collections counter just because that's been in our mind recently, but it wouldn't really work well because if we know that there's one of something, we've got the order, and if we know that there's two or more, well, we don't know where the later ones were, so that wouldn't keep our info that we want. So another way you could do it is to make a list comprehension for all the good ones. So I could say, like, often people will use n for a number, or you could say x, x for x in list. If x is not 0, that could be our first half of the list, all the non-zeros. And then I could say plus the same thing with an equals, right? So I could say, hey, look through the list and find all the non-zeros, and then look through the list and find all the yes zeros, right? And that would probably work for everything. Yeah, that would probably work for everything. And if I hit attempt just to check all the big tests, yeah, it's fine with those too. So what are some things that you might change about this? Well, you might say, this is looping through the list twice. It looks through the whole thing and counts all the non-zeros, and then it looks through the whole thing again to count all the zeros. In theory, if it's a super long list and maybe the comparison takes a tiny bit of time, this might be inefficient. Shouldn't be a big deal, but you never know. You might say, I'd rather loop through the list once. Okay, we can do that. You could say, for example, something different on this second part. You could take the length of the original minus the length of this new guy, and then do 0 times that, len of list minus len of the new guy. How do we give the new guy a name? Well, we could say, that's a question. Do you put an E on the zeros plural? Some people put zeros with an ES. The author of this question put zeros with an S. I think one is British and one is American, but I don't know. I think math people put ES most of the time. And ES is what came naturally to my fingers when I typed it, so we'll go with that. Could we do that? Well, I guess. That's kind of ugly. And while I'm sure it would work, let's make sure. Yeah, that's fine. It's pretty long, pretty ugly, and behind the scenes, I don't really know how the len works. Maybe it loops through the whole thing to count, or maybe the list keeps its own len ready to go for when you ask. We'd have to check on that. Another way to do it is to say these comparisons aren't really needed to directly check for a 0. We could say if x, because 0 is false, every other number is true, and that works. So let's go back to our slightly nicer looking original, where we say x for x if x, and then we say if not x, because the non-zeros are truthy and the zeros are falsy. That works as well. You might have a list someday with mostly numbers and a couple other stuff. If there's like a none in there, or a false in there, or an empty string in there, and then depending on your situation, you might want to move those to the end with the zeros. You might say, hey, I'm looking for only the good stuff that actually has genuine content in there, and I want that in the front of the list, in which case this would work. Or maybe you actually want to target zeros, move them to the end. Maybe you're going to use pop to get them off, for example. In that case, this might be a bad idea because you'd get some nuns and falses and other things mixed in with your actual zeros that you want. And now that I'm thinking about this, I could use the bool function. B-O-O-L means, you know, is this thing truthy or falsy? So you could imagine going sorted list key equals bool, and that's going to say, you know, 1 or 0. And I guess that means we'd have to go reverse in order to get that. But I kind of like that, and the sorted loops through or looks through once rather than going through and then starting over again. Is it faster? We could test. It's not a big deal, and I don't think they give us any huge inputs of a million numbers or anything. Do they specify? On the random tests, they don't give any long ones at all, so we're not worried. But it's something to keep in mind. You could say a different key that might switch our Boolean to make it not need to be reversed at all. That works too, and that looks pretty good. I think when you see x equals 0 right at the end, you know that that's what we're looking for. So fair enough. Let's check these solutions from other people and maybe get genuine new breakthroughs, or maybe just kind of similar ideas sprinkled around. Okay, this one did, they're checking for bool and 0, so they're saying, hey, I genuinely want actual integer zeros and not falses that are pretending to be zeros, even though false is an integer, blah, blah, blah. This person is being really specific, and that might be what you need in some circumstances. This one is using remove and append to take a 0 out, put it back, which is fine. However, that does modify the original. So if somebody passes you a list and they're expecting a new one, you're messing with their original, and that might be a surprise to them later. This one, I wonder if maybe an earlier version of the problem had some falses in there, and that's why people were checking for the bool specifically. Or maybe the directions mentioned it and then they cut it out or something. This one looks nice. You take the non-zeros and then you do times the count. Probably the shortest way so far. This one, you start a new list, and yeah, there must have been something in the directions or something in the tests that I didn't see or that has been changed over the years, mentioning the bool thing. So that's great to see because there are a ton of possibilities. Here's another one that sorted the original rather than making a new. Here's one that did the long version of the comprehension. Here's one that did the short version of the key. All kinds of considerations, even in a short problem.